Hi again, it's Pierre. Today we're episode 3 of that camera crane project, and I'll just give you a little overview of what's going to be done today. Let me just get around the parts, and I'll show you how they fit, how they do, and how we done it. Okay, last time I showed you a little bit of the parts. There were some steps that were done maybe before showing in the episodes, but this, which is the part that goes onto the tripod fixture, and that will be used as a base and adapter for the rest of the material. And well, today we're going to be machining these UHMW rings. They're open. I made them closed, but now they're open. The reason for the slanted cut, like just been done on this, it will be placed on the adapter like this, and the fact that it's being slit, you know, like if I can show this good. Oh yeah, you can see that it's being slanted, the cut. It will avoid straight cut that will, you know, as soon as something hits in it, it just like opens up by itself. So that will stay closed, and that will make a continuous surface all along. So the two bushings bearings have been cut the same way. I'll align them opposite when I put them first, but it won't matter that much anyway. And also, like, we machined this this top part, so the arrangement will be like this bushing will do the axial, let's say the axial holding, and this one here will be a little bit like a truss bearing on top. The weight's going to be applied to this one, and the lateral forces will be applied to these ones here. And since the camera and the crane and mounting will be mostly balanced, because I'll put a counterweight in the back, these actual bearings won't work too much. The majority of the weight will be supported by this truss bearing here on top, which is like, it's not turning fast, it's not turning like you know, it's not going to be ending up at the let's 500,000 kilometers on the odometer. It just turn once in a while, you know, and it's not generating any heat or anything like that. And this material, UHMW, is very self-lubricating. It just like it slips. And now I'll just show you how it fits on the other part that will hold the arm. It's already done. Give me 1 second and we'll get there. The way this thing is meant to go, we've got this adapter here, which goes on the head of the tripod. It goes on this here. This is going to be fixed there, held in place, glued and screwed on top, and I can't demonstrate with the tripod attached to it, but this is going with the truss bearing in the bottom. I'm not putting it I just show you how it goes, where it goes, you know. But this is going like this here. It slips with slight pressure. It's not loose fit, it's no tight fit, but you have to just press a little bit on it, and this is gonna hold the let me get you closer. There's gonna be a space here, a little bit less than the space of this on the top here, because now it's got a little bit deeper. I have to adjust the to trim the length of this to get the right the exact right measurement. But this is no loose. It's a snug fit. Rotates with a, you feel a slight pressure on it. But since the crane itself is going to be like 4 feet or something long, I mean, it will just like butter. It will turn just like butter, just very easily. So I'm not worried about that. So this is going there, slightly pressured, and these, you know, if they wear out, it's easy to make. It's easy to make other bushings, but they'll last like many years. I mean, I'm not worried about that, and it's very nicely, you know, nice feeling to it. Just it's like you had small amount of damping, but not enough to impair the movement or anything like that. It's very supple. So today, making these things, those UHMW's bearings, bushings, this cap, and we're also making the grooves into this this adapter. That's what this step is all about. One thing before we start, I'd like to mention with these kinds of polyethylene family type plastics, which includes Teflon, Delrin, UHMW, all these kinds of plastics. I highly suggest you use some high-speed steel, you know, well sharpened, expressly for that. I've been a little bit lazy on this project, and I use the, you know, minimal standard. But you can ease the life for yourself for cutting those. Now let's get at it, and you see how we go through that, and just some new material for this episode. UHMW. Make the sliding bushings of a UHMW. Let's face this. We'll make some hole inside of that, and since we're using a boring bar after, we're not going to worry about centering. Okay, this is good. We'll be boring this. Let's try that speed, but I'm not too sure. Going good. Okay, let's measure this. Okay, 1 inch 7,000. So I need 450. Okay, I need 1.450. You can take huge cut to this. Let's make it 1.4. That's 400,000. Okay, so you can make huge cuts with this. Like 400,000 is a decent cut. Let's make sure we're still in the right measurements. Oops, we gotta change the measuring tool. Okay, that's gonna be able to kind of make up for the, you know, like one way on one side, one way on the other side. Okay, let's go. I'll cut this probably. Let's face the end. Okay, we're just on the verge of turning too fast. Diameter on this. Not sure that knife is doing a right job though. Okay, 1.807. Changing tool. Okay. Let's say 510. Already been better. It's too fast. I'm making a mess of this. And it's not the right tool. Let's switch. But this a high-speed tool usually does a better job. I should have started with that. Okay, we'll slow it down a little bit. I think like 375 should be fast enough. kind of too lazy to really put something else than a parting blade. Seems to be doing good. Okay, let's see how much left we got. Because if you heat this up, you're cooked. Seems to be doing good. Not too hot. I think we're pretty close on what we need. We don't use the this tool as a C-clamp. I think we're not bad at all. Keep it like that. $1.150. So in there we need to let's say, I'm just eyeballing again, 375. Okay, 3/8 2 times 375. There's one. Okay, 375 again. Okay, 375 again. Number 2. We have a little bit of cleaning up to do. This is a kind of a they heat up a little bit and they just deform, but that's okay. Final result is one going there. There's one going near the top, and this is going to be the bearing bushing, so it just like slides easily. They're gonna overcome this surface by about 15,000 on each side. Let's say the other surface will be you won't touch this surface for 15,000 of an inch, so that's plenty enough to make sure that we got some wear time on this. Need to make another one. That's going to be on the top of this. The other one's going to rest on top of that, so it won't touch this part there. It will just lean on one of those bushings there, and don't worry, it's going to last for many years. It's going to be not very thick. I need about I don't know, 100,000 tick is going to be more than enough. Okay, I need 1.475. Let's measure this. .5, 21, 22. Okay. 475. Let's say 125,000 tick. Problem with this sometimes is the cutting knives don't always get perfect thickness. That's fun. Wife's coming home with the flu. Yuck. Okay, back at it. About it. Oh, perfect. There's just a little pip in the middle. Okay. Yeah, this is solid. Okay, got the message. There you go. Hey. Nice little bushing. It's gonna act like a ball bearing. Okay, now I've got these all it's gonna be used as bushings and bearings. We'll make the groove in the adapter part. We'll make the groove that will make it possible for to hold the these things here, because they're going to be cut and put on, just put on this there. I need to make a groove that's going to be 375 wide and no, I'm not gonna use this cutter. Use something else. That doesn't make something as square as a good carbide insert. and I can measure the carbide insert more reliably. There. Another time 60. Okay, 375 minus 118, 257. I gotta move. Okay, I'm gonna give 3 thousandths clearance. Let's go 60 again. Now we'll clean up that groove. I want to see what I'm doing. I got about 1 or 2 thousandths more to go down, so okay. With a parting blade, you can go sideways a little bit, at the condition you don't have too thick of a cut to do. A few thousand is no problem. There you go. Okay. Looks good. Gonna do the same thing at the bottom of this. Go for 60 down there too. Remove. Oops. Okay, remove 257. It's going to be 260 because I want to give a little bit of clearance. 60,000 down. Minus 50,000 for the finishing cut. 58. 58. 58. it over 60. Okay, that's clean. That should be nice. Just clean up the gonna use a Scotch-Brite just to clean up the burrs on the surface, and that's it. I'm gonna keep the sides pretty square because I want the UHMW not to slide from there. This is very nice. They won't slip over, that's for sure. Have to split them open. I'm gonna keep that for a little later. This is the end there. That it's gonna make the top just like a bearing on the top, and 2 bearings there. I think that should be solid enough. It fits, yeah, fits nicely. Fits nicely. That one too. Yeah, we're in business. I think I've had it for today. I'm kind of out of it. My improvising tolerance is is dead for today. So let's turn it off and we'll come back tomorrow.